Namaste everyone and welcome to session 3 of our series Algebra for CAT, where we are picking up question types and then creating a theory for attempting those question types and getting them right in no time. So let's move ahead with this particular session, where we'll cover a very important category of questions which are based on inequalities, where arithmetic mean is greater than or equal to geometric mean. So let's understand this very quickly. What is it that we need to remember while attempting such questions? So always remember when we're talking of positive values. So let's say we say x is greater than or equal to 0. So always remember arithmetic mean is always greater than or equal to geometric mean. So if I take two numbers, let's say x and a reciprocal of that number 1 by x. So what will be the arithmetic mean of these numbers? X plus 1 by x divided by 2. This will be the arithmetic mean. This has to be greater than or equal to the geometric mean. What is geometric mean? Under root of product of numbers. So under root of product of numbers would be x into 1 by x. You can cancel this x with x. And now if I cross multiply, I'll get my relationship as x plus 1 by x is always greater than or equal to 2. So remember this, that when x is greater than or equal to 0, you are supposed to keep this in your head at all times, that any number and a reciprocal of that number. So don't always remember it in the form of equation. Any number and its reciprocal when added will always be greater than or equal to 2. And it is equal to 2. X plus 1 by x is equal to 2 only at x is equal to 1. So this is important, given that x is greater than or equal to 0. Now, if x was less than 0, suppose if it is given that x is less than 0, then the situation changes to x plus 1 by x will always be less than or equal to minus 2. Remember this, x plus 1 by x will always be less than or equal to minus 2, and the equality x plus 1 by x will be equal to minus 2 will hold true only at x is equal to minus 1. So if you put minus 1, minus 1, minus 1, it will be equal to minus 2. This is the only possibility. Remember this, at x equal to minus 1, they become equal to minus 2. At x equal to 1, x plus 1 by x becomes equal to 2. So if you remember this, we can move ahead and create variations on the same. So when I say variations, think of two numbers which are a square and b square. Can I now say I can apply arithmetic mean greater than or equal to geometric mean, because these numbers definitely are greater than 0. So I'll have a square plus b square by 2 will be greater than or equal to under root of a square into b square. So I can then say a square plus b square by 2 greater than or equal to under root will be equal to ab. I can cross multiply and I can say a square plus b square is greater than or equal to 2ab, or in general, ab is always less than a square plus b square by 2. This you could have easily derived using a minus b whole square as well. So other alternate way to arrive at similar relationship is, we know that any whole square will always be greater than or equal to 0. So we can say a square minus 2ab plus b square will be greater than or equal to 0. We can take 2ab that side. So we'll say a square plus b square greater than or equal to 2ab. Whichever be the case, always remember that sum of squares of two numbers will always be greater than twice the product of those numbers. So repeat, sum of squares of two numbers will always be greater than twice the product of those two numbers. And very quickly, we are going to see application in questions that have appeared in CAT on similar lines, so that we understand why are we studying this in the first place. So I hope this much part is clear. Then the next part that CAT has thrown with regards to an greater than equal to GMB, that they have thrown trigonometric expressions and simple expressions, not really complicated ones, like sine and cos. So always remember that any value of sine x will always range from +1 to -1, which means whatever be the value of x, you will always have the expression being in the range of -1 to +1. So you have sine 0 as 0, sine 90 as 1. You will never be able to get any value of x for which it is greater than 1. And same is the case for cos x. So any expression inside cos, we don't care what the expression is. Whatever be the expression, we know that the value will lie between -1 and +1. So remember these two important relationships, that cosine function, sine function always range between -1 to +1, which means if I now ask you in alternate way, what is the maximum value of sin x? You'll say 1. What is the minimum value of cos x? You'll say -1. What is the maximum value of cos x? 1. Minimum value of cos x? -1, and so on and so forth. So just remember this in your head very, very clearly. Then the next part is the similar expressions that we have covered so far, but in the form of indices. So think of any positive number, let's say like 2. And if I now say 2 to the power x, just think about it, irrespective of the value of x, can I say this is always positive? So 2 to the power x, always remember, is always positive. Even if you put x as negative, 2 to the power -3 would become 1 upon 2 to the power 3, which will become 1 by 8. So if you put 0, this becomes 1. If you put positive value, it will keep on increasing exponentially with powers of 2. So understand that this expression is always positive. And now if I give you this expression 2 to the power x plus 2 to the power -x. Now what does it mean? The moment you look at this, you should be very easily able to convert it in your head like 2 to the power x plus 1 upon 2 to the power x. And if I assume that let 2 to the power x is equal to p, can I then say that this expression translates to p plus 1 by p? Remember what we just learned? Any expression plus reciprocal of that expression when that value is greater than 0. Remember, this is always positive, greater than 0. So this value will definitely be greater than or equal to 2. So in general, the moment you see an expression of this type, always remember that this will be greater than or equal to 2. Super useful as far as questions in CAT and GAT are concerned. I hope this much is clear. Now it's time for us to move to questions straight away. So we'll take few questions from previous year's papers so that we understand why we have studied. That's it. This is the theory, and we'll be able to solve at least 5 questions now based on this concept. So let's look at this question. While multiplying 3 real numbers, Ashok took one of the numbers as 73 instead of 37. As a result, the product went up by 720. Then the minimum possible value of sum of squares. The moment you see this expression, minimum possible value of sum of squares, it should click in your head that somewhere you will have to apply AM greater than GM. Some relationship that you would have studied that gives you minimum value. So they are saying they multiplied 3 numbers. Let's say the 3 numbers be A, B, and Ashok took one of the numbers as 73. So let's say one number was initially 37, but while multiplying, he took that number as 73. As a result, the product went up by 720. So if earlier the product was P, now the product became P plus 720. So it's very easy to formulate the two relationships. If I now subtract first equation from second, can I say P will get cancelled out? On the right hand side will get 720 and AB as a product will be common. 73 minus 37 is 36. So AB into 36 is equal to 720. I can cancel this 2 times, so it becomes 20. So I now know that the product of 2 numbers other than the ones that Ashok took is 20. That is what they are asking, minimum possible value of the sum of squares of other 2 numbers. So other 2 numbers are A and B, the product is 20. Just now we did this relationship that A square plus B square by 2 is always greater than or equal to AB. So I need to calculate minimum value. I can cross multiply this 2, or you would have better remembered it like this: A square plus B square greater than or equal to 2AB. So I can just substitute this value here and I can say A square plus B square will be greater than or equal to 20 to the 40. So it will always be greater than or equal to 40, and therefore minimum value for this question will be 40. That's our answer. Very easy. I don't think there is anything difficult in this. It's just that sometimes you are not aware that what to do after we get ABS 20. Believe me, a lot of people will be able to read this part very quickly, but they'll struggle as to what to do now. Should I do hit and trial? You'll get the answer any which way, but then this is probably the easiest way to reach your answer. Let's look at one more question of similar type. So if sum of squares of 2 numbers is 97, and this is from CAT 2018 slot 2, sum of squares of 2 numbers is already given. So I already know that A square plus B square by 2 is always greater than or equal to AB. This sum of squares of 2 numbers is given as 97. So I am given 97 by 2 is greater than or equal to AB. So 97 by 2 is 48.5 is greater than or equal to AB, which means the product of 2 numbers is definitely less than or equal to 48.5. They are saying which of the following cannot be their product. So this product has to be less than 48.5. Minus 32 is less than 48.5, 16 and 48. All the other three options are less. Look at option 1, 64. Clearly, this is not possible because the answer has to be less than 48.5. Correct answer for this question is option 1. Very, very easy. And as I like to call it, ridiculously easy. So let's move ahead to the next question type. The number of real roots of the equation. Again, we just studied this, that the expression for cos, the maximum value that this can take is equal to 1. So if I look at this expression, so if I quickly look at this expression, can I say that the max value here will be equal to 2? Max value, because anything inside cos, maximum value is 1, 1 into 2 is 2. And this is an expression in the RHS that we are again very familiar with. The minimum value of this expression is 2. 1 is max, LHS is max, right hand side is min. Both can be equal when they are both equal to 2. So LHS equal to RHS has to be then equal to 2 for this equality to hold. When does this hold? We just concluded that this happens only at one value, which is x equal to 1. Let's put x equal to 1 and justify. And please remember to justify always, because you might have right hand side getting justified, but left hand side might not be getting justified. So if I put x as 1, sorry, this happens only at the value of x is equal to 0. So if you put the value as x be equal to 0, you will get 2 into cos of 0, which is equal to 1. So 2 into 1 is 2. And you put x equal to 0, again right hand side is 2. So the only possible solution for this is at x equal to 0, and that is what they are asking, number of real roots. So the number of real roots is just 1, the value being 0. Correct answer for this question is option 3. Let's look at a similar question now, which has a trap. Number of real valued solutions of the equation. We are given this equation. Again, understand CAT 2020 slot 1. The same type of 2 to the power x plus 2 to the power minus x is getting repeated. We know that this expression has a minimum value of 1. So minimum value of 2. And because this is 2 minus some number, can I say that number is whole square and therefore positive? Therefore, can I say the right hand side value, the right hand side has a max value of 2. Again, both of them can be equal when both of them are equal to 2. Same concept. So when can this be 2? This will be 2 at x equal to 0. Let's put x equal to 0 here in RHS. So if I put x equal to 0 in RHS, what is the expression that I get? I get 2 minus, if I put 0, I get 2 square, which is 2 minus, which is 0 minus 2. So we'll have minus 2 square, which in turn is essentially 4. So I get minus 2. So understand that RHS is minus 2, but LHS is 2. Both are not getting equated. This was the only possible value where this could have happened. X equal to 0, because we have a minimum value, we have a maximum value. So the only way this could have been equal would have been at x equal to 0, but that is not getting justified, and therefore correct answer for this question is option 2, 0. No solution exists. Let's look at the next question in this series. So number of distinct real roots. Understand that they are asking for distinct real roots, and the expression that we get is x plus 1 by x. So the first thing that we can do is x plus 1 by x to be equal to p, where we now know that p will either be greater than or equal to 2, or p will be less than or equal to minus 2. Remember this part, because it is an expression of a number plus its reciprocal. Either the expression will be greater than or equal to 2 or less than or equal to minus 2 for all real values. Otherwise, we get imaginary answers. So x plus 1 by x is p. Let's quickly simplify this. P square minus 3p plus 2 is equal to 0. If we solve for the roots, it's very easy. Product is 2, sum is 3. The roots are 1 and 2. Is 1 acceptable? No, because it has to be at least greater than or equal to 2. So the only possible solution is when p is equal to 2. What was p? X plus 1 by x. This is equal to 2. So the only answer that we are going to get is when x is equal to 1. Correct answer for number of distinct real roots for this question. Therefore, theta based question, you'll put the answer as 1. Pretty easy, very straightforward, just based on one simple concept of AM greater than equal to GM. So I believe this is what we wanted to cover when this particular episode was sort of. I hope that you've learned some very interesting concepts. So now we have had 3 sessions on algebra for CAT, where we've picked up certain very interesting question types. In fact, this concept of episode 3 will spill over in episode 4 as well, where we are going to cover another set of 5-6 questions based on similar lines with the same concept. So make sure that you attend all these sessions, create notes, write down specific relationships in your formula notebooks, use them wisely before you appear for every mock, maybe after every mock, so that you remain in touch with some of these concepts that are getting repeated over and over again in the CAT exam. That's it from my side. I'll take a leave. Sure.